A lot of definitions. So if I give you a definition, know what it means. What does QC mean? What does QA mean? Okay, so go through and look at your definitions. I ask a question about the responsibilities of the medical physicist. So go through and look and see what they do, you know, what that person does. What are their responsibilities? I ask a question about the advantages. So which of the following would not be an advantage, would be an example of that type of question. So make sure you understand the advantages and the disadvantages. Maybe the two of quality assurance, maybe what are the two parts of a quality assurance testing? That's patient care and image interpretation. What does TJC stand for? You know, what is it that they do? Oh, here are the 10 steps. Do I have another 10 steps? I'm sure I do.
Is there a reason why it's called 10 step, but it's actually 9 steps?
Pardon me? It's the TJC 10-step program.
But it's actually 9 steps? Is it?
Well, you know, they can't count.
Oh, okay. Okay.
Don't tell them I said
Okay.
that.
I don't really have a specific
Question on that. Okay, patient care. What does quality control mean? Okay, when should equipment be tested? When do you test equipment?
When you get it?
When you get it.
When you get it, and that's called acceptance testing. And then you have a scheduled testing, so if it's yearly, semi-annually, whatever, that's, you know, your scheduled testing. And then what else, when else should you test?
After it's been fixed.
When it's broken. When something's broken, it's fixed, and then you need to test it again. Okay, so if you test something and it fails the test, what do you do then?
Schedule maintenance for it.
You will retest it. That's like calling the computer geek out to fix your computer and it wasn't plugged in.
Oh, one of those
You
customers.
always retest to make sure that you didn't do something wrong. And in fact, that's what you're supposed to do. Retest it again and make sure that it is out of compliance, that you didn't do something wrong, you know, with the testing, just to confirm it. And then what do you do? Especially with our digital stuff. Then you're going to call service.
Mhm.
The days of me being able to fix stuff by hitting it are obviously over.
That always
I've
works.
hit every piece of equipment in here and then still have to call somebody. So it doesn't work anymore. Know your quality control tests. These are, know the type of test, how often it's tested. Really, these are all annually except for this one, wasn't it? So that's different than the rest. Make sure you know your limitations. You have some labs, your linearity and your repeatability. You had those, so make sure you know those numbers. So make sure you're aware of those. And I think that's where we stopped on that. Ooh, did we? You know, I have a question. I can throw it out, or I could just leave the answer.
Answer 3 point.
I don't know if I talked about it or not. I took out this section, so I think I probably took out a slide that went with it. When we did film screen imaging, do you know what the number one reason we did a repeat radiograph? And I don't really have a lot of.
Is in technical factors?
Yes, technical factors. Getting the right MA, KV, and time to get, either we were over or underexposed to get, you know, an acceptable radiograph. You know, that's why the technique book was so important. Writing down that write MAKB in time for a hand, for a skull, whatever it is we were taking an x-ray of, so that was very important. Now, it's not important at all. It's, you'll get to know your mass, but even working it with the new equipment, and that's what you're gonna have out there. What are you looking at? When you go to make an exposure, what is it that you're looking at first? Mass, isn't it? And then you change, then you look at your time and MA to see if that's the kind of time you want. And that's where it's going to. You're just looking at your mass and making sure that the time is as short or as long as you want it to be. So that's not going to be an issue anymore. In fact, how often should you repeat a radiograph because of an incorrect exposure?
Never.
Never, never. So now, do you think you don't have any repeats now? You don't ever have to repeat a radiograph?
Yeah.
That's not, you will be repeating a radiograph. Why? What's the number one reason digitally that you'd be repeating a radiograph?
Part positioning.
Positioning, clipping off, not rotating properly, that sort of thing, not the right angle, that sort of thing. So the number one reason for you to repeat digitally, you repeating a radiograph would be positioning errors. But yes, repeat radiographs. Now, you know what we used to do every time we took an incorrect, we had to get rid of a piece of film because of incorrect whatever. We had either a slot with our name on it or a barrel that everyone put their repeat radiographs in, and somebody would every 3 or 4 months go through it and look to see why we were repeating. Was it over or under exposure? Was it a positioning problem? People collect the repeats different ways. Sometimes we had, I say a slot or a place that, Lynn and Tammy and Susan and whoever we were, we'd put our repeat radiographs in there. Mm-hmm. Oh my gosh. I mean, and so it'd be like, Lynn got quite a few up there. So it got to be a problem. That could skew your results. What do you think people did? Not me, but what do you think people did? Yeah, he took them home, threw them away, disposed of them secretly somehow, right? Okay, so they got rid of that, and so we just all put our rejects in a barrel, and then every so often somebody would go through there and see, but did that get us out of the hot water? No, because why?
Your name's on it.
Yeah, we have our markers on there. And really, a repeat rate is not to hire, or not to fire anybody. That's not the purpose of a repeat. And so just keep that in mind because they will be looking at your repeats. The repeat is to see if you need help with something. If all your repeats are in the oblique lumbar spine, which you haven't learned yet, and it's a little tricky. So if all your repeats are, or a lot of your repeats are that oblique lumbar spine, then we need to help you and give you tips and maybe a little quick in-service. If the whole department, oh my gosh, we are not good at our oblique lumbar spines, let's talk about some tricks. Miss Erica, you're always getting yours, so what are you doing that you can teach the rest of us? that sort of thing. That's what it's supposed to be for, is to see any kind of pattern. So whether it's as a department or as a person. So now we're not putting film in a barrel, but you will be designating your repeats based on electronically, so that those will be recorded somehow. As a student, your repeat rates are imperative and very important. Why?
To see if you can move on from.
Well, yeah, to see but why would Mr. Siegel want to talk to you about your repeat rate and look over what you're repeating?
Make sure that.
What are we here for?
To learn, teach us.
To help you. So if you are having a lot of repeats in a certain area or in general, you need help. If you've got a repeat here on a chest and a repeat there on a spine and a repeat over there on a skull, that's no big deal. But if you have a lot of repeats, we want to look at them and then see where the problem areas are to help you. So keep that in mind. He's going to be talking to you today, and he will be talking to you from now on. Just know that that's the purpose of him going over repeats with you and making sure you understand what you did wrong. That's the number one thing, not the number one, that's one of the many things that we have to do as a tech, is to correct our mistakes. We're gonna make mistakes, always, but we need to learn how to correct them. So if you don't know how to do that, when you position something and you don't know how to correct that, then don't take it again. So it's that sort of thing that the repeats are important and are not to be used punitively. We have a policy. Do you know what our policy is? We haven't really gone over the policy manual in depth, but do you know what our quote policy is? It was before Mr. Siegel got here, and then he tossed it out the window. What was the repeat rate that was acceptable? 5%, which I think is very low. And then as a student, do you think that's hard? And he's like, forget that. Why have an unreasonable repeat rate? And guess what? When your repeat rate, you figure it out, it goes to 6% to 10%. Now what are you doing as a student?
Freaking out.
Now you're freaking out. Are they going to dismiss me or not? And of course not. A lot of times we used to previously, again before Mr. Siegel, with the previous clinical court, we really didn't look at repeat rates unless there was an overall issue. And then we would go back and go, oh, okay, this makes sense, the repeat rate is higher, whatever. So he doesn't use it for that for any reason. His purpose of the repeat, he'd rather you try something new and fail and get a repeat than to not try it at all. And so I think he's going to talk to you about that. Listen to him when he tells you things like that, because he means it. So anyway, okay, I got a cookie. Okay, so let's get this over. Let's talk about, okay, so digital, what are we talking about? QC, digital QC. Listen to me, digital QC. All those other things we talked about, filtration, linearity, repeatability, collimation, we still have that in the digital world. We still have X-ray tubes with collimation. We have generators that give us MA and KB in time. We still have to test for those things, okay? That doesn't go away. Another part of QC was a processor, was the film response, were the screens, that goes away. So what's in place of that? Digitally, what's different from film screen to digital is how we look at the image. So now a lot of our QC is based on the display of the image, which would be the monitors. Okay, so that's what a lot of this is for. So your book, oh my gosh, that chapter in your book, if you even looked at it, is just a bunch of alphabet soup. We looked to, when I say we, not me, we looked to the film industry, the television industry, to look to see what they did for their movies, for their TVs, and their imaging practices, and have taken a lot of that for our monitoring. I should have a picture of it. This is, again, alphabet soup, but this is what is being used to look at the monitor. What do you think we want to look at when we're looking at an image on a monitor? What are some things, what are some issues that we would have in looking at a monitor? Even just looking at your pictures, anything that you have on a monitor, what are you going to want to see? You're going to want to see your different shades of gray. You want to make sure your resolution is good. Is your detail good? All of that sort of stuff, is black, white's whites, do you have quantum model, do you not? And so you want to look at all this stuff to make sure everything's okay. So this is part of the industry. I don't know, growing up, again, 100 years ago, back at the turn of the century, on the television set, the TV did not go all night. Did you know that? Did you? No, you don't. So, okay, so at whatever, 10 o'clock, whatever time it was, it had, at the end of the evening, it had some sort of device with lines and different colors maybe, and that was their testing pattern. That was their test pattern. And so, like I said, we've developed it from them. And so, GSDF, what does that mean? Every time I see GSD, biology, radiobiology people, genetically significant it's not what it means. So grayscale, D, digital function. Grayscale, digital function. So that's what we want to look at. The grayscale. Is the image showing all the shades of gray? Have you ever sent one document from one computer to somebody else's computer and it came up all different? That's why we do those PDF files, so it doesn't get changed in transferring. Can you imagine sending a beautiful x-ray that you see on your computer at the hospital to another hospital? Are they gonna be able to pull it up and see that same quality of image that you took? I don't know. So these were all the things, the issues that they had to come across when they first started doing digital imaging. So when we transfer images, would it not be important going to a radiologist for them to look at it wherever they are? Whatever hospitals, or you take that image here at this hospital, send it to that doctor. You would want the quality of the images to be maintained. And so when we transfer images from one place to another, or even in the same hospital, you've heard this term before, maybe you've heard me say it, DICOM, Digital Imaging and Communications, and that means that every piece of equipment we have in here is what we call DICOM compliant, meaning it can communicate with each other through a DICOM system. If that printer wasn't DICOM, I could not send an image that I took from this room over there to it. You know how you put it in the imaging, the cassette in the imaging plate reader, and it goes to the printer? It could not do that. It could not go to the monitor without having it being DICOM compliant. Okay, so again, it's mandated for all displays. Now, your book, when you look at it, there's a lot of different types of tests that can be performed for looking at the image. But for digital imaging, we've adopted the American Association Association. I don't care. Anyway, TG, that's the one we want to know. It's the Task Group 18, okay? And they use this. There's quite a few, as you go through your book, there's quite a few different ones, but this is the Task Group 18 Test Phantom, or what they have QC pattern here. So they have all different shades of gray. They have patterns here that you can look at, that some have poor detail, some have very good detail, and so this is the pattern that they look at. Here are just some of the other ones that are also used. And so again, just looking at, what do you see here? Line pairs per millimeter, so they're looking at things like that. So what does it mean? It means nothing to us, but when you're performing your test of the monitor, whatever the criteria is that you're supposed to look at, whatever, you're supposed to be able to see this pattern clearly, you're supposed to be able to see this many shades of gray, whatever the criteria may be, when you see that pattern, each and every time it comes up, it needs to be what?
The same?
The same. It needs to be consistent. Okay, so that's what we're looking for, consistency. Okay, the other thing that is looked at is the monitor brightness and color. I'm not in PowerPoint mode, sorry. So, in order to test the brightness of a monitor, you would need a luminescence reader, a light reader, okay, for that. In your book, it shows you how you would actually measure different areas of the monitor. You don't just measure in the center, you measure at the edges, and all that luminescence has to be within certain parameters. Okay, so all of this is, I'm not going into detail because it's more than is what a health physicist would do. Somebody who works on the equipment. I've seen the Philip rep come out and do some of those test patterns. When they installed the GE machine, they did some of those test patterns. So it's more for your service engineers to come out and make sure that your monitor is appropriate. If the monitor is a color monitor, then that would need to be measured also, or tested, and make sure that it was appropriate. We also look at geometric distortion. So we have two types, there are actually more, but there are two types of distortion that we can possibly have. Pincushion and barrel effect. I want you to know the difference between those two. And a barrel looks like a barrel. What we're looking at here is a wire mesh pattern. So these are wire lines. It's just a piece of wire mesh, laid over and being imaged. And so if you're looking at your monitor, this is a distortion and this is distorted, correct? And so your pin cushion is where it looks smaller in the middle and gets larger towards the periphery. Doesn't it look like that? In actuality, the mesh is the same throughout. So when you have no distortion, all the squares will look the same size. On a barrel distortion, it's bigger in the middle. The wire mesh squares look larger, don't they, than they do at the periphery? So that's your barrel distortion. So you can, neither distortion. Do we like distortion in radiography? Typically not. Typically not. So we don't want that in our image, and it can't vary more than 2% in any direction. So which one is A?
Barrel.
Barrel, and which one is B?
Pin cushion.
Pin cushion. So this is what we're looking at. This is a fluoroscopic monitor, and we use that to look at our images. And what do you think about that? Is that pin cushion
Pin
or
cushion.
barrel?
Pin cushion.
It is pin cushion. It looks smaller. Do these squares look smaller than the squares out here?
Mm-hmm.
A little bit. So that's your pin cushion distortion. What about this one?
Pin cushion.
Barrel?
Barrel.
That's barrel. It looks bigger here, smaller than the outside. That's a cow, you little city slickers.
Oh, what a cute dog.
We slaughtered those back in Texas. Okay, reflection. Reflection of the monitor. This is important also. Look in your book. There are some pictures, which I have. Specular and then diffuse. And so here's one. And so you have to turn the lights off to look at that. Can you imagine being a radiologist reading from this monitor and you have a reflection of the light overhead? Okay, so this is specular. Specular means mirror light, so it's like you can see the outline of the lights, overhead lights. This is diffuse, where you see shadows of it. It's not clear, but it's still there. So that's the difference between the two. How do you test for that? Get the image off the monitor and look at it. So some of these tests can be pretty simple. So it says turn off the monitor and visually look, or get your test pattern out for that also. So some things to look at. So again, the task group 18, the quality control pattern is used a lot. Here's another one. It's still task group 18, just a different pattern for noise. They have lots of different patterns, but again, the task group 18 is the one that we use for our digital display to look at. So, luminescence response. So what does that mean is how the monitor, about the brightness. And so we look at from the pixels to these other things. Look up tables, digital driving levels, presentation values of the pixels. So we want to make sure, and we talked about measuring the light response. We can also measure the pixels response and how they respond to luminescence. So let me ask you, what does TG stand for?
Test
group. Okay, task group. What does DICOM stand for?
Digital
Digital
imaging.
and communications. And again, no definitions. Okay, so look in your book, look at those definitions. So what are we testing for when we look at the monitor? We're looking for brightness, luminescence. We're looking for geometric distortion. And resolution. What else? What did I say?
Brightness and resolution.
And distortion. Brightness, resolution, and distortion. Hang on. One more thing. How often do you think they test for? How often do you think they test for this?
Every 3 months?
How often would you look at your monitor to see if it was working appropriately?
Weekly, monthly, semi-annually. Daily.
Every day.
Daily, regularly, all the time, because any one day it goes off, right? I say this to my, hang on a second, I say this to my my computer techs. It was working fine until today. I said it, I call Phillips all the time. It was just working, right? And then it's not working. It's like, I don't know what happened. And they're like, that's what happens with computers. So you'd want to test,
Right.
or not test, but look at it regularly. So a radiologist would come in, turn on their monitor, this comes up, they do their check, and then they're ready to go. They do their check, doesn't look right, turn it off, turn it back on, do their check, not right. Phone call to somebody, probably to the lead supervisor, Miss Claw. Yes. You're next. How many, everybody?
16. First 16.
16. 1-6. 1-6. And I'm making sure you know all of them.
Can you go through those questions?
I just did.
She just did. Are you ready?
You should be able to take a test right now.
Just re-listen to your distortion.
Okay. Okay, so listen up. 2 more minutes. Let me just tell Mr. Siegel to come on up. And then I'll tell you what's going to be on the rest of the test.
I gotta go to the bathroom.
You have to go to the bathroom.
And Dr. Feinessa.
Oh, yeah, thank you.
I really do gotta go though.
Okay, who am I calling? Okay.
You're calling Mr. Steve.
Right?